Hi all, in this video I want to share to you a function generator I made that even beginners on PCB design can make, as the design is really simple. But first, remember to subscribe. This video is sponsored by PCB Way. More on them later. So let's start by reviewing the schematic. As always, I separate all the components based on their function, so the schematic is more readable. I always put the power flags on the top left corner. Then I have here the first block, that is the voltage input. Really straightforward. A screw terminal, a diode for basic reverse polarity protection, a switch to turn power on and off, and a capacitor. Moving on, we have the Arduino Nano block that contains all the connection with the Arduino. I have all the labels here and the pull-up resistors for I2C interface. Then we have the 3 push buttons that serves various functions on the board and respective pull-down resistors and labels. Down here we have the encoder with the 2 pull-up resistors and the pull-down for the push button. And last we have our connectors. Well, we can now move to the PCB design. As you can see, the overall layout is really simple and there aren't so many traces. So here I have the screw terminal with the minus and plus on the 6 screen. Here I have the diode, the switch, and the capacitor. Then we have the Arduino Nano, the AD9833 and the screw terminal outputs. Down here we have the 3 push buttons and the rotary encoder. To give a better look at the PCB, I also insert this label here. For the traces, I used the 20mm for power traces and 10mm for signal traces. Oh, and at the output here, I also added test points for probe connection. And also these 4 M3 mounting holes. This is the 3D view of the project. As you can see, I have all the models except for the AD9833 module. I think it's really good looking, and I always love 3D renders of PCB projects in general. I want to give you all the various angles so that you can see better. Remember that to change view here on the 3D viewer, you can use X, Y or Z, or Shift X, Shift Y and Shift Z. Okay, now it's time to test our PCB. But first, let me thank my sponsor, PCB Way, who provided the PCB used in this video. If you want really good looking PCB, I highly suggest to check PCBWay.com using the link in the description. They can also assemble PCBs for you or offer 3D printing and CNC machining, with tons of material to choose with. Just check PCBWay.com, link in the description. Okay, there we are. Now we turn it on with the switch. You will see it 1000 square. So at the beginning you will see 1 kilohertz square signal, and we can navigate through the various digits. Set to 3000. There we go. Pretty back down. 4, 5, 6, and so on. Let me go up, so 16. Let's okay, see 16 kilohertz. Then you can go 26, 36, and see the square wave is pretty fine. Okay, now let's go to the hundreds of kilohertz range. There we go, 366 kilohertz, and it's still a square wave. By the way, I cut the limit to 1 megahertz, but if you want through the code, you can go even higher. This is 960 kilohertz, something like this. By the way, you find the code in my GitHub page on the description. Okay, let's try triangular waves at 66 kilohertz. Pretty good. Let's go a little bit up, 166. Pretty fine. 200, 300. Let me rescale a little bit. And okay, let me remove this thing. Yeah, it's pretty good. Let's go up, let's go up. At 900 kilohertz, it's getting like a little bit Sine, you know. The spike, it's not more a spike. Let's try sine wave. At low frequency, I expect this to be like obviously good. By the way, this is rated at like 12 megahertz, but yeah, I really doubt it. Okay, still a sine wave, still a sine wave, still a sine wave. Let me go a little bit up. Now this is at 900 kilohertz. Yeah, it's pretty good. I mean, the sine is still a sine. Okay, let's now try at the maximum frequency of 999 kilohertz. And the sine wave is a little bit wiggling for some reason. Don't really know why. Maybe it's my scope. For the square wave instead, we have yeah, it's a square, but it's buggy. Don't know again if it is my scope. And for the triangular wave, yeah, it's like a rounded triangular now. It's a little bit wiggling, but yeah, could be good. I mean, could be better, sure, but yeah, this is at the maximum, by the way. Yeah, that's it. Okay, that's all for now. Thank you for watching. See you next time. Bye.